Well, hello there, and welcome to Educate Your Way. Today we're going to have a look at something a little bit different. We're going to have a look at complex numbers. Now, with complex numbers, right, I think what you've done is you've heard most of your friends call them imaginary numbers. It's the cool thing that makes it sound like you're doing such hard work. Imaginary numbers, we've got to imagine the numbers. It's something like that, but not quite like that. All right, let's have a look at the first example here with these imaginary numbers. Now, what is an imaginary number? Well, remember this whole thing about us saying the square root of a negative number? It doesn't happen. Well, now all of a sudden it does, right? We call that a complex or an imaginary number, right? The square root of -1, we need to define it as something. If we're going to use negative square roots, we have to define them as something, right? I mean, that's sort of how it works. So we defined the square root of -1 as I, so they called it I. That is now the square root of -1. And the way other numbers now work around that changes because you're making the square root of -1 a value when you use it in questions and equations and additions and subtractions and operations. The rules are going to change for you a little bit, right? Because now it's not the square root of -1, it's I. It's a number that is able to interact with other numbers. We just need to find out how. And that's how we get that I is equal to the square root of -1, which makes I squared is equal to -1, which means I to the power of 3 is going to be equal to -I, which means I to the power of 4 is going to be equal to, I have I here, that's a mistake, is going to be equal to 1. Right. And what that means is that any of these multiples of 1, 2, 3, or 4 will be equal to the same thing. So I to the power of 6, since 6 is a multiple of 2, will be -1. 15 is a multiple of 3, so we're going to get -I. I to the power of 16 is just 1 because 16 is a multiple of 4, right? These are things that you just need to pick up when you're working with imaginary numbers as a result of me making I the square root of -1. Now, let's move very, very quickly to write it. And how do we write numbers in a real and imaginary form, okay? So here I have 4 plus I, which I've already told you is the square root of -1, right? I have 4 plus I squared. When I expand this, I get 16 plus 8I plus I squared, right? And we know from here that I squared is just going to be -1. So it becomes 16 minus 1 will give me 15 plus 8I. But in any expression or equation which has an imaginary number, I always separate it into my real form and my imaginary form because both of these things do not play by the same rules. So keeping them separate is very important going forward, and you'll see how that happens in previous operations. So I really hope that you're following how we expand these things out, as well as how changing the I squared to -1, a real number, helps us simplify these expressions into something like this over here with a real part and an imaginary part over here. Also hope you're quite comfortable with the fact that I is square root of -1. I squared becomes -1 because that square root of -1 times the square root of -1 is -1. I to the 3 is -I. The reason for that is that you put another -1 over here. This part over here now becomes -1. And you have -1 times the square root of -1. But I've already said that that's going to then be, you have -1 which is times the square root of -1, which is already called I. So we just say -I over here. I to the 4 is 1 because if you say -1 squared, it's just going to give you 1. So I hope that that's all following. Now let's come up here to our imaginary numbers and how we use them to solve equations. Now here's something you've seen a lot in your life. X to the power of 3 or x cubed is going to give you 1, right? I mean, that's really straightforward. But x cubed equals to 1, the answer should be 1. But let's see what we do. We bring the 1 to this side, we factorize the 2 cubes, we get x minus 1 and we get x squared plus x plus 1 over here after doing some factorization. You should have learned this in grade 10, how to factorize these cubes over here. And now you'll see we get x is equal to 1. But we also get this answer over here because when we put this into the quadratic formula, this is the other quadratic that came out of our factorization, we get -1 plus minus the square root of 1 minus 4 over 2. And this 1 minus 4 can just be written as the square root of -3. Now, we have a problem because we have a square root of a negative number, right? This is wrong, right? No. We can rewrite the square root of -3, and that's how you must always rewrite negative square roots. We can rewrite it as, we can say this is now -1 plus, this is the square root of -3 times the square root of +3 times -1 over here, right? And remember our rule with surds. When we have surds, we can take out a square root from a square root. So I can rewrite this part as, over here, square root of 3 times the square root of minus 1. That's exactly what I'm going to go ahead and do. I'm going to write it as the square root of 3 times the square root of minus 1. If only we had something that we could call the square, we have I. And that's the square root of minus 1 then becomes our I over here. And all of this is over 2. And obviously, sorry, this one here is plus and minus. And there we have 2 separate answers. We have 1 plus the square root of 3 times I all over 2 as one of the answers. And we have 1 minus the square root of 3 times I over 2 as another one of our answers. And now if we need to use these 2 answers for any practical purpose, we have a way of representing them. That basically is what this I does for us. Okay, I think I got some stuff over here. Here we say the conjugates. That's the conjugate over there, right? Okay, now what you will realize over here is when I solve this, because of this plus minus nature of the square root thingy, I get 2 answers. I get 1 plus my imaginary number and 1 minus my imaginary number when I have a square root where b squared minus 4ac or quadratic where b squared minus 4ac is less than 0, and I get a negative value under that square root. And that is where the conjugate comes into play, right? Over here we have z, and I'll put a z there, and z is equal to 8 plus I. The conjugate of that will be 8 minus I, and because of this little way of us using imaginary numbers where it usually comes up in the quadratic formula, if 8 plus I is a solution, generally 8 minus I is also a solution because of the nature of how this quadratic formula over here looks. Right, so we get 8 plus I, and then z, this little star or dash on top, this little star that you put on top, it means that's the conjugate. And the conjugate is very, very important, which will be 8 minus I in this case, is very, very important when we work with complex numbers, especially when we divide complex numbers. Because complex numbers are so tough to work with in that there's a real part and imaginary part, they become even tougher to divide. So one of the best ways we can simplify complex numbers of this form over here is to multiply by the conjugate over the conjugate, right? So if we have 3 minus I here, we know of the denominator, the conjugate is 3 plus I, we multiply by both. This is an I at the top, by the way. We multiply by both. We multiply by 3 plus I over 3 plus I, and it's effectively the same as multiplying by 1, but by multiplying by that conjugate, we can ensure that we get an I squared. That's a big lesson for you. When you want to try and simplify and make sense of these complex numbers, the conjugate becomes very important because it gives you an I squared at the end. That I squared just becomes negative 1, something we can simplify, something we can reason with. So we put this in here and we get 12. This is 4 plus I times 3 plus I gives me 12 plus 7I plus I squared. But we already know that I squared is minus 1, so this just becomes over here is minus 1. We get 12 minus 1 is going to give me my 11 down there, and we get 11 plus 7I. Got to keep the real part and the imaginary part separate. Over here, we get 9 minus I squared. That comes from the difference of 2 squares present here, so we get 9 minus I squared, but we know I squared is minus 1. 9 minus minus 1 is going to give me 10 down here. Separate the answer into the real part of 11 over 10. We got our imaginary part is 7I over 10. That is how we use the conjugate to help us simplify these expressions over here. Now, the conjugate becomes even more important when we talk about the roots, because I just told you here that if the positive of, if we have 1 plus something as one of our roots, because of this plus minus nature that we find in our quadratic formula, and we generally find in our multivariate degree, cubic, and quadratic formulas, what happens is that if z is a root, so too must the conjugate of z be a root, right? And we'll see how this sort of plans out over here, right? If we have a situation such as follows, where we have x squared plus 3x plus 16, okay, and you're asked to then find the answer to this over here. You go to quadratic formula, you say x is equal to minus b will be minus 3 plus minus the square root of b squared is 9, but 4 times 1 is 16 is 64. So we get 9 minus 64 in this case. We're ending up with negative 55 under that square root, all over 2. Now, what you will see here is that straight away, again, like we had over here, this minus 55 can be rewritten as the square root of 55 times the square root of I. So we go square root 55 times this I over here, and we get that over 2. But if minus 3 plus square root 55I over 2 is an answer, then the negative also has to be an answer because of the symmetry of the quadratic formula. So we get minus 3 minus square root of 55i all over 2. And that is something that we can take advantage of when we read questions like this, where they say if 6 minus 2i is a root of a quadratic equation, right? How do we find that quadratic equation? Well, if something's a root, right, then this over here must be the factor x minus whatever the root is. So we get x minus 6 minus 2i, and we get x minus 6 plus 2i, because we said the conjugate also has to be a root in these sort of things, right? It works the same when we get answers that are surds in these things, right? If I tell you in a certain quadratic that, I'm just going to use your space, that 3 plus the root of 5 is an answer, you know straight away 3 minus the root of 5 is also an answer, because these two things could never be added into each other. So your two answers must be this plus it and this minus this over here, because you can't add them up. So you can't get different answers, right? Or different looking answers. And that's the same thing that's happening down here. So we know these are our two solutions. What is the quadratic going to be? Now you could write out like this and do a little bit of expanding, but it's going to take you forever and it's going to lead to mistakes just because how complex this whole thing is now. So here's the formula you use when you are expanding a quadratic where a conjugate, and it's a conjugate and a number root that you have. You're going to say x squared. You're going to say a plus b, assuming that this part is a and this part over here is b. Now let me tell you why. The reason is that just a plus b will just be adding up your real numbers from these two, because minus 2i plus 2i will cancel out. So you end up with an easy 12 there for your coefficient of x. Now for your constant is going to be a multiplied by b, right? And what you're going to see over here is that when you multiply these two, it's just a difference of two squares. So you end up with 36 minus 4i squared, right? But 36 minus 4i squared, remember that's why we do it in the first place, because we get this I squared over here and it kills us, because we get minus 1 instead. So 4 times minus 1 is just plus 4. And that gives me my 40 over here. That is the best way to expand these things given one of the roots of a complex quadratic. Alright, I really hope that this opened up your eyes to some of why we use I as an imaginary number. Really hope that you enjoyed the video. In the next part, we'll look at how better ways of modeling this real and imaginary part so it can be slightly more useful. But this would be a good starter. See you in the next one.